Before I begin with the whole workshop, I'm just wanted to give you guys some of the announcements that Nicole was supposed to give you guys, so she asked me to do it. Okay, just some just some things that you guys should have access to. Like, so this should be the survey, the entry survey for this entire cohort. Just you guys have access to the QR code. Let me just do that. Okay. Okay. You guys are taking a picture right now. That's fine. Just make sure you scan that. Okay. And all right. Okay, and with that, these are just some of the upcoming events that we have this week. We have, this is for the game dev workshop. Okay, we're gonna have the Blackboard. Okay, with Ricardo over there. He's gonna be doing this workshop. And this is the QR code if you guys are interested in that. So make sure to scan it. Okay. Perfect. Awesome. And lastly, this is just the init FIU trailer. I think this is a new stuff, right? Yeah. Just so you guys could watch it, okay? And this is the QR code. Make sure to scan that to watch the init FIU trailer, okay? While I'll set up everything here. Okay. All right. So I think this will be it for now for all the PM presentation. Okay. So before I get started, do you guys have any questions regarding the last workshop or anything at all? Okay. But I mean, just feel free to ask anytime. Okay. I'm good with anything really. So I'll be changing here to my iPad. So to get started with the actual stuff, right? Okay, so this is gonna be the agenda for today. We're gonna talk, well, so in the last workshop, we talked a little bit about Python, which is the programming language that we use in AI in all kinds of aspects. And after that, so for today, we're gonna talk a little bit about the history of AI, then some of the main sections of it, like AI, what exactly it is, machine learning, deep learning, which is AI and LLM, okay? Just the concept stuff, nothing crazy. And after that, we're gonna talk about the difference of training data and testing data, which is huge, extremely important for this entire thing of AI, okay? So we're gonna go over data, okay? After that, we're gonna talk about the three most important types of learning in AI, okay? Which are supervised learning, unsupervised learning, and reinforcement learning, okay? And at the end of today's workshop, because it's gonna be 2 hours, right? So we're gonna go up until 6, okay? And so lastly, in the last part of today's workshop, we're gonna talk about a famous model, which is a beginner model, which is called KNN, K nearest neighbors, okay? So let's get started. Okay. So AI definition, okay? Okay, so what exactly is AI? Does anyone have any kind of idea what exactly what that means? Yeah.
Is it like a computer modeled after a human?
Yeah, that's the idea. That was actually the idea behind building AI, which was like to mimic the human brain, okay? The aspect of how the neurons in our brain works, okay? But what if I told you that in the history of AI, this is actually kind of an old technology? But the question is now, if this is an old technology, why are we just seeing it now? Like, what was the piece that was missing back then? Can anyone tell me? What was missing in the past? Yeah. Maybe that's too much. Okay. I don't like that. What is it?
Maybe more powerful computers.
Powerful computers. Yeah, sure. It's very important. But there's just one word that I'm looking for. I mean, it's right here. Yeah.
More data.
Data. That's the word. In the past, we didn't have a lot of data that we could use to be processed and to actually train the models that we have today. Okay. And these are then the two main factors of building an AI model that we need. We need a lot of data. We need data, and that's the thing that you're always gonna see when you're working with AI. You're gonna always be working with data. AI is data, okay? And not only that, another thing that is very important is powerful computers, and more specifically GPUs, which is a hardware piece that we can use to train a huge amounts of data and this fast, okay? That's why this kind of stuff is very important in today's days, okay? Any questions on that? But very interesting, right? Okay, so let's talk about a little bit some of the AI concepts, okay? So first we have like a general idea, which is basically just AI. So you can think of AI as like the whole thing, and this is basically grouping all kinds of systems that we can use to predict or basically classify any kind of stuff. Something that that is smart enough to make smart decisions, okay? But with that, with AI, we also have machine learning, which is ML, okay? And in machine learning, I want to first to give you guys the idea that at the end of the day, this is not magic, okay? And all of the what it is just math, okay? All of it is just pure math. So if you want to work with some kind of research in AI and go even more in depth, you're gonna have to like math. Sorry to bring that. But yeah, and in machine learning, the kind of math that we work mostly is just basically statistics, okay? Which is not advanced math, but that's the kind of math that we use for machine learning algorithms, okay? But inside that, we have deep learning, which is a more advanced type of AI, and that's the part that we are really trying to build what we have in our brains, with trying to make neurons into computers, which is a very crazy idea. And the math behind that we use is linear algebra. I don't know if you guys are gonna take that class. I mean, I had to take it. It was for a computer engineering major. I'm not sure for computer science. No. Yeah, but if you wanna go with, and study deep learning, you should learn linear algebra. Okay, it's the math behind that. Okay, we're gonna talk more about that in the future workshops and building our first neural networks, which is all in deep learning. Okay, so don't worry about it. Any questions before I move on? No? Okay. You guys can just say anything at any time, okay? So don't worry about it. Okay. So remember when I told you when I was talking to you about the missing piece that we had that we were looking for to work with AI? So this is it, data. and why data is so important. Can anyone tell me just broadly what data is?
Information.
Information, perfect. Yeah, so that's what data is basically. It's just a piece of information that can be related to anything at all. Anything in the entire world. But when we are working with data in AI, you have to keep in mind that we are always gonna have two different types of data when working with AI, okay? As you can see here, we can have a whole data set, which is this whole thing right here. But then, when we are trying to implement this kind of data in our AI model, we're always gonna have to split the data into a training set, which could be this larger portion right here, and the testing data set, which is another portion, smaller portion right here. Can anyone tell me why do we have to split our data like this into a training set and a testing set? Yes.
Because if you train the model on all the data, it'll only be used to that subset and not be more generalized.
Yeah, that's the idea. Yeah. So yeah, the main idea behind why we're trying to split is because we are trying to make a very general AI that can work with a lot of different data sets, not just this one specifically. So what I mean by that is we're gonna have a training set, which is gonna be this data used to build our model, okay? To work with all the math formulas to be able to make predictions or any kind of classification. And then, in the end, we can evaluate our model with a testing data set. And the reason why we do that is because we want to test our model with unseen data. Does that make sense? Because we don't want our model to just work with just one specific piece of information. We want it to work with everything, right? That's why we use a testing data set to make sure that our model is good, okay? Any questions on that? No? But it's very interesting, right? And usually this could be like, in most models, this could be like just an example, 70%, and testing data could be 30%. Just some numbers. But it's actually just up to you, okay? Okay. So let's talk about our first type of learning model, which is supervised learning, okay? Okay, so here it is. So the main thing that I want you to understand about supervised learning is about the data the type of data that we give to our model. And what I mean by that is that it's always going to be labeled data. Here, labeled data. What do I mean by that? Is that, for example, we have a data set of fruits. Right here we have apple and strawberry, okay? And when we give this data set to our model, we're always, oh yeah, that works. We're always going to give it like, okay, so our AR model, so this is an apple. We're always saying here, an apple, this is an apple. And again, this could be a different picture, just with, I don't know, like another angle of an apple. And then we say it again. So, model, this is an apple. This is what I mean by labeled data, okay? And now we can do a different type of fruit now. So model, this is a strawberry, okay? And the reason why we do that is because when we include this kind of labeled data and then we send it all to our machine learning model, the machine learning model is gonna work with the math, all the math behind it, to make sure that we can understand the features that make, for example, an apple. And with that, I want to talk to you about an important concept in AI. Let me show you right. Let's do new. And now, these are the two important concepts now: target and features. Okay. So target is basically what we are trying to predict, or we're trying to classify as, okay? And so with that in mind, what do you guys think would be our target right here with this data set? What would be the target?
The fruit.
The fruit. Perfect. Yeah, that's it. So the target, which is what we are trying to classify as, are the fruits. We're trying to classify a new fruit as an apple or as a strawberry. So that's our target, okay? And you guys, when you guys work with like a real data set, this would be like a column, okay, in the table. And I'll show you guys later, okay? Perfect. But not only that, we also have the features right here, which these are basically just the characteristics of some fruit, which could be of an apple or a strawberry. Just said it, but perfect. So yeah, so features are basically the kind of things that we want our machine learning model to understand, to be able to predict or classify something as in the future. Okay. So for example, let's say when we want to predict something, I give something with like color, like dark red, and then circular shape. Okay, if we give these two specific features for the AI to be able to predict the fruit, which fruit do you guys think the machine learning model is going to predict it as? The apple, right? So you guys just did the way that a machine learning model works. This is it. You guys have any questions so far? But this is very interesting, right? And in the real world, this is the most used one. This is the most learning structure that we use. Okay. So again, just to review everything. So supervised learning is when we are working with labeled data and we give this to our machine learning model to understand the features for each of the targets, and then we use those features with the targets to be able to predict future elements. Okay. Okay. So you guys might have heard, like I was saying, like when we're trying to predict or classify something. So this is what exactly I mean. In the supervised learning models, we can either do regression or classification. And basically, when we do regression, which is this one right here, regression, we are basically trying to predict numbers, real numbers, okay? Continuous values, okay? But not only that, we also have classification. And classification, we don't have for numbers to be precise in that. We're trying to like predict if something is like either here, blue or green. So you guys can see that we're not talking about numbers here, okay? This could be a more general idea. But regression, on the other hand, we are actually trying to predict numbers. Can you guys give me an example of regression, like in the real world, that we could use?
The weather, maybe, to predict?
The weather, but what exact, like the temperature?
The temperature.
Okay, yeah, perfect, that's regression. What else?
Stock prices.
Stock prices, yeah, I love that one. So you guys can see that regression is all about numbers, okay? Now can anyone give me an example of classification?
I have a question.
Yeah,
So,
of course.
so with I assume between what we just talked about with classifying the fruit, that would be classification.
Yes,
right?
yes,
So-
perfect.
But with
What?
that, the computer would read that data as numerical values, right?
I'm gonna talk more about that I think in the next workshop, but yes. So yeah, the idea is perfect because computers can really understand like
Right, it doesn't see an image, it sees it.
exactly. We would have to turn into numbers. Like for example, apple can be represented as 1 and strawberry is 0. And then the output is either 1 or 0. See? But this is very important, yeah. But yeah, so the last one with apples and strawberries, it was regression or classification?
Classification.
Classification, right? Because we were trying to classify a fruit as a strawberry or an apple. Perfect. Now let me just quickly try to access this. Do you guys have any questions so far? Be it anything at all? Any insights as well? Any ideas? Okay. Let me choose. Okay, so I'm gonna do something fun right here. There's an website online. It's called Teachable Machine, which is like a live representation of machine machine learning model working at like real time. So can I get a volunteer here? Yeah, come up here, please. Yeah. Can I get some applause for him? What's your name? Sorry.
Adam.
Adam. Okay, Adam. Nice to meet you. So what I'm doing here, I'm just gonna ask you, basically, just to explain what this is. We're gonna try to build an emotion detector. Okay. And right here, what is the first thing that we're gonna need in a AI model? What is the most important thing? Data, exactly. So now we're gonna collect our data. Does it have a webcam? Okay. Oh, okay, perfect. So Adam, could you please make a happy face right here?
You just take record.
Yeah, hold. You have to hold it to make a lot of data samples. Just hold it, and yeah, and you can change your angle of your face. Yeah, happy face. So this is your happy face. Okay. Okay, that's too much.
Not too much.
No, it's okay. It's okay. But now let's do a sad face, and it's just the same thing. And now this is your sad face. A sad face. Okay, awesome. And now an angry face. Okay, so it's sad face. Love it. Okay, so now that we have our data, okay, but first, so what type, this is supervised learning, but is this regression or classification? Classification, perfect. So now we're going to train our model right here, and we're training data. Okay, you can see that it might take a while or something. Oh yeah, perfect. Okay, so now that we have our training data, now we're gonna have a testing data to make sure that our model is working. So Adam, could you make some kind of face right here, and you see, and we can check our model is working.
Looks very angry.
Well, for some reason it's not detecting a happy face right now. I mean, this kind of stuff can happen all the time.
Oh, there you go.
Oh,
It's happy when I back away.
oh, maybe it's because you were
Oh,
back.
that's a good point.
Okay, so this is like a hack face.
Got it.
Hey, can you do a sub face the way you did it? Oh, awesome. You can see that it's not always perfect, okay? So this kind of stuff can always be deprecized. That's why this could be a very like an interesting thing to work in, because it takes a lot of work and time to be able to process all of this stuff. Did you do the angry face?
Yes.
You did it?
Got it, yeah.
You got it? Okay. So thank you so much, Adam. And this is available in the Explore mode. And one more time for Adam. Thanks, Adam. Okay. It was fun, right? And again, you can actually work with any kind of stuff right here. It doesn't have to necessarily be like a happy. It could be like a, you can literally like use the apple and strawberry, put it right here, and you can build the same thing that we were talking about. Perfect. Oh, and this is the link to the website that we just did, the Go Machine. Okay, if you guys want to try it out, feel free. Just move this right here. Okay. Okay, now for our next type of learning in AI, unsupervised learning. So, different from a supervised learning model, the main key here is that our data is not going to be labeled. Instead, we're just going to give the data with just the features. But what would be the purpose of that? So what is the idea with unsupervised learning? So the main thing that we can do with this type of data set is actually trying to group stuff, okay? So for example, okay, so for example, if we have this data right here with these data points, and maybe we want to group it into, I don't know, could be 3 groups, okay? So how could you group this data? It could be something like this, and something like this, and something like this. This is an example, okay? But it could also be something like this, or this, or this. So here we are trying to group three aspects of our data set. And why could this be important in the real world? Can anyone think of something that this could be useful in the real world? Yes.
Maybe like pattern recognition.
Perfect. Yeah. Yeah, I love that. And more ideas?
Position maybe? Position of something?
Coordinates.
Yeah.
Probably, yeah. Like to identify the coordinates of certain groups. Okay. Love that. So yeah. And when we are trying to make these groups right here, these are called clusters, okay? It's a very important concept in unsupervised learning, okay? It's right here, clusters, okay? So how could you see something like that in the real world? One example is, for example, let's say that we have a small company, and we have this could be the number of customers and how often they come to our store or something. And then in the end, you can try to group different aspects to understand better our customers. Does that make sense? This is a way that we can use unsupervised learning in the real world, for example. Okay? Any questions on that? So again, supervised learning. We are working with labeled data. And unsupervised learning, we are working with unlabeled data. Okay? So these are the 2 main ones so far, okay? Okay, this is gonna be fun. So before I get into that, I wanna first try to do an experiment. So we have right here in this classroom these positions right here and each of you is a data point, okay? I wanted for you guys to make 2 clusters. Can you guys find the most optimized way of a circle or something? So which one would be the centroid or something? Could you guys try to, from where you're sitting, okay? Just say this is group 1 and this is group 2. Okay, so we have okay. Raise your hand if you think you are in group 1, which could be this side over here. Okay. And so all of you right here would be in group 2, right? Do you guys think that this is optimal? No. Okay. So now we're trying to move a little bit the clusters to this side now, okay? So let's say that you are the center of cluster number 2, and you are the center of cluster number 1. Which of these 2 are you guys closer to? Okay. Raise your hand if you think you are closer to him, and keep your hand down if you think you are closer to him. Okay, interesting. Yeah, this is kind of more optimal, maybe. Maybe you could move a little bit more. Guys think? So let's say more to this side right here. If you're, I'm just moving the centroid. Yeah, more right here. Okay. Maybe you're trying to make a more even split. Okay, now raise your hand if you think you are closer to him now. Okay. Yeah. But you guys see the idea of how this works? We gotta keep moving the centroid, which is the thing that we're gonna be trying to move it closer to. Right here. Let me show it. So this is what we've been doing just now, okay? So we gotta pick some middle centroids for our data right here. So for example, this is like the random position. And then all of the data is gonna be trying to see which one is gonna be closer to, the closest to, okay? So like, and these are all closest to yellow, okay? But the thing is, when we take now the mean of all of these points right here, now we see that the new centroid is gonna be right here. And when we take again the mean of these data points, then the centroid moves again to this point right here. And then we do the same thing again. See which one now we are closest to. So this is like the new one right here. And like which one this is gonna be closest to the yellow. Okay? And when right here. Oops, right here. So now when we do the mean again with this new data set, we get that the mean is gonna be somewhere right here for the yellow portion. And when we do for the red ones, we move it right here to this middle, right here. And it's gonna be this one now. And we do that until we get an optimal solution right here. So yeah, we do right, it goes to this part right here. And we keep doing that, these changes of centroids with the positions until we get an optimal solution. And when that is when the centroid is at the center, when we do the average right here, the mean. For example, when we do the mean of these new data points, we get is going to be specifically at our centroid. So there is no need to change the position. And this is going to be the new group for the red one. And the same thing for the yellow. When we do the average here, we get that the mean is going to be right here. Does that make sense, guys?
Yeah.
So you guys can see that the idea with this algorithm to group stuff is that we're going to keep moving these kind of centroids to be able to select better our groups, okay? And see what data sets their data points they're going to be closest to, okay? And then we keep doing that until we have an optimal grouping selection. Perfect. And what we just did, this is actually the KNNs model, which is unsupervised learning algorithm, okay? And now, if you guys, let me show you. So this is like a real a data set that I built, okay? And for example, here we have like some customers, okay? And we have like the annual spending and the monthly visits. And as like the CEO of this company, we want to understand our customers better. Maybe we want to group some customers that are like more valuable customers and some not that valuable, okay? And this is what we're gonna try to code now, okay? So let me show you guys the Explorer Hub now, if you guys want to get your computers on to try it out. So this is the Notion page. You guys should have access to all of this. So we are at cohort 2, and then we go to AI workshops, and we can find everything right here. Okay, you can just click on this link and you should be able to have all the coding. And this is it. Okay. Let me know if you guys already have this.
Yeah.
Okay. If you guys are having any kind of trouble, just raise your hand, okay? And we're gonna try to help you. So this is the Google Colab, okay? You can always, if you don't want to, you can always work with the VSCode, okay? Which is another IDE, but this is the online one, okay? Are you guys good? Any kind of trouble, just let me know, okay? Okay, so this is the workshop 2, right? And the first section that we're gonna be doing right here is the unsupervised learning. And when we open that, the first thing that we're gonna do is import some libraries that we're gonna be using. And this is mostly what we use in the AI world. So we're gonna use pandas, which is the one that we use to work with data. Matplotlib, which is this one right here, which is the one that we use to for data visualization, okay? And scikit-learn, which is the one that we're gonna use to import all of our models, okay, machine learning models. And the one that we're gonna be using is KNNs right here. So you can run that, okay, just to make sure, right here on this button. And then we're gonna get our data. And this is this, sorry. And so this is our data right here is in a dictionary, which is like a data type that we use to label stuff. So with the customers, we have all of it right here, monthly visits, with all the data points. This is the X, and this is the Y, okay? And now we're gonna turn this data into a data frame that we can work on. And then right here, these lines are just to plot our data, which is what we just saw. And you can just run that, okay? And this is what we get. So, but now I wanna ask you, as the CEO of this company, and you want to group these customers, in how many groups do you guys think we can group these data points? 4? 4? Just 4? You guys think 4 is the most optimal one, okay? Okay, so let's do 4, okay? I didn't hear any more numbers, so let's do 4. So right here, we can go to this cell and write our training data. And you guys can write this code right here, okay? And you guys can do KNNs, which is, we are trying to build our model that we're gonna be used to training, okay? And now we're gonna import the class to make our object, which is KNNs. And then we're gonna include some important parameters, like the number of clusters, and we set 4, right? So we put 4 here. And another parameter is just to make like a stable random state, okay? Um, in a more general way, it's just 42. We don't really change that, okay? Now that we built our object, we can run that. Oops, sorry. State. Render state, yeah. And you can run that, perfect. So we just built our model, okay, right here. And now, the thing that we're gonna need to do is to make our model predict this data set to group this data, okay? And this is what we're gonna do. We have our object, so we can create the prediction right here. Cluster is gonna be KNNs, which is our object, and we're gonna access the method, which is a function, predict. Wait, fit predict, this one. And the parameters is just gonna be our data set right here, the df, okay? And then what do we want them to predict? We want to maybe, okay, oh, this is better. Cluster equals to, and then we do k-means, and what we're trying to predict is df, okay? We do double right here to make sure that we are passing as a data frame, okay? And these are the features: monthly visits and annual spend. Just need to make sure that it is the same thing. Okay, I'm just gonna copy because it's case sensitive and everything has to be the same to be able to work. So we can just copy it. Yeah, monthly visits. Yeah, I think it's right, but just make sure. Okay, yeah, it was right. And now we can run that. Perfect. So now we just built our clusters, okay? And now the only thing that we have to do is just plot our new graph with our results. So we don't have to change anything here. And to be honest, guys, like when I'm working with machine learning, and in the end, I just want to plot my results into some kind of data visualization. I honestly, I just do ChatGPT because it's just very annoying. This is just like repetitive stuff to write. So I don't really worry about that. So, and then we can run that. And right here, so wow. So this is our group that we just did. So we have one group right here. Okay, it's good. Oh, I like that. We have another group right here. And these two are like the most valuable customers for our company. We have a yellow and there's like a dark blue or something right here. Interesting, right? Do you guys want to try any a different number of clusters? Or other than 4? 2? You guys want to do 2? So the good thing is that we can just change it right here in the parameter. So the number of clusters, we change it to 2. And then we run that, run the prediction, and run it again. Perfect, yeah, so this is it. Yeah. So like this is to be like important, like in the real world, for example, if we have something like this, and then we could show it to the people in the company, right? So that when we have like someone like at this point right here in the data set, then like we know that this is gonna be a valuable customer. Interesting, right? So this is with 2. And we have it's separated at this point right here. Interesting. And these are the centroids that is like the mean of these positions. You guys have any questions? Yes.
Just like in general,
Yeah.
when working with like, I guess a larger scale AI model, can you like import APIs for like large sets of data, possibly?
You mean for like this one?
I mean, just in general, like if you're just trying to build an AI model of like something, and instead of like mainly importing a whole bunch of data, can you like import an an API
Mm-hmm.
for like multiple sets of data?
Uh, I don't know. I think sure. Yeah, I don't have a reason to say no to that. Mm-hmm. I mean, because honestly, like in the real world, our data set is gonna be enormous, gigantic. Like in the last workshop, we're actually gonna build a whole project together, so you guys can put it in your resume, and like you guys gonna see that like the data set is gonna be used like really big, really big. So big that it took like an hour for my computer to process everything. I'm serious. Yeah. I could even hear like the fan for my computer. It was funny. But yes, it's gonna be for the last workshop, okay? So what time is it? It's 5. Okay. So this is unsupervised learning. We just saw supervised learning, and I'm gonna do a little break now, like a 5 minute break, okay? And then we're gonna continue, okay? So let's take a break now. And if you guys have any questions, you guys can just talk to me, no problem. Yeah, of course. Oh, okay. Yeah, of course. So you can just write this go dot fiu dot edu slash explore code, and this is like the Notion page with everything, and then you go right here, down here, and you see cohort 2.
Yes, no.
And in this hold up, right here. Down.
Oh, here.
Yeah. And then you should see the Notion doc.
Yeah.
And right there, workshop 2, you should see the Google Colab.
This one.
Yeah.
Okay, thank you very much.
Of course. And you just let me know.
Yeah. Can you go back to that page that we
Mm-hmm. You mean?
the Google Colab?
Oh, yeah. This right here?
Yeah, but can you go off where you the code? Yeah.
Oh, yeah, of course.
Yeah.
Yeah, sorry. Yes. Oh, you're doing VSCode. Did you install the libraries using the pip install? No. Okay. We're actually gonna do more of VS Code. Can I go? But like this is Mac, right? So the way that I do, I'm gonna actually explain more the way we can work with VS Code in the next workshop. But you could actually like I remember that when I was like in the beginning and I was trying to do all of it, and what really happened the most was like working with ChatGPT. And so what you could do here, so what we should do here is install these libraries. Okay, and the way we can do that is we create a virtual environment, okay, and then we install it. You can actually ChatGPT that, and I think you should like give you all the details and the comments, okay? The Google Column? Oh, you should run this first one. Yeah, you run this. Wait. Yeah, now you can run that. Yeah, it's like you just have to run everything like this. Yeah. Did you run this? No. You should. Where is that one? Now, yeah, no, sure. You see there right here, KNNs.
Oh, sure.
Yeah, that should be it.
Oh, yeah, thank you. Of course.
more minutes, just to make sure that everyone's back. Yeah, I see some computers. Okay, okay, guys. So now I'm gonna be. I hope you have some time to go to your bathroom, have some water, and now I'm gonna talk a little bit about the last type of learning. Okay, for today. Okay, which is gonna be reinforcement learning. Okay. Before I get started with that, do you guys have any questions regarding anything previously from the okay, if that's the case, so let's get to it. Reinforcement learning. Personally, I really like this one. And guys are gonna understand why. So the main idea of reinforcement learning, when I was trying to understand what this kind of AI training is, you can think of it as the same way as like training your dog or your pet or something. I have a little dog, and his name is Peter. I like it from Spider-Man. And when I was trying to teach him some sit or I don't know, lay down or something like that. How would I do that? So I'll have some kind of treat, and then I'll say Peter, sit. And if he did sit, then I'll give him the treat. But if he didn't, then I will give it to him. What's the idea on that? Is that to make him understand what is a good behavior, what I want him to do, and what I want him to change. And this is exactly the same way that we can work with this type of learning, reinforcement learning. So what we have here, we have a system, could be like our model. Let me just change that color. We have our model here, and with our model, we're gonna have some kind of environment. And what do I mean by environment? You can think of environment as like the place where our AI is gonna try to do something. Okay, this could be actually some kind of gaming, and could be like, for example, if you're working with robotics and you want him to walk into some path, okay? And in this environment, our model, it could perform any kind of action into this thing. An action right here. And it's gonna perform something right here in this environment. But the thing is, after it takes the action, it might go into, it might receive a reward, which means that it is a good thing. So then it's supposed to get a reward. Or if it's something that it is not supposed to do at all, then it's not gonna be perceived as a reward. It's gonna go as an observation to try something else. Okay, to not do that. And then this is the idea right here. So basically, again, when we have a machine, this type of model, we can have a reward or an observation like this. And now I have a question for you. If our model goes over and over and over again into this environment, taking many actions, getting a lot of reward, a lot of observation. Do you guys think this is good or bad? Good, right? So we wanted to try to make as many, we wanted to understand this environment as much as possible, right? Well, the only thing that is gonna take a lot of computation, right? So this is the only thing that we have to consider. And this is the main idea behind reinforcement learning, okay? Now we're gonna actually do another fun activity right here. Okay. You're gonna actually play tic-tac-toe with AI right now, okay? So, I'm gonna use a piece of code here. It's available in the GitHub and in the Explore Hub, okay? And just change it right here. Okay, so this is actually a full code for reinforcement learning. I'm not gonna go too deep into that, mainly for two reasons. First, because I didn't write this actually, I just implemented into our workshop today, and also because this could be maybe advanced for today, but I just wanted you guys to get a grasp of it, okay? So, this is the collab, okay, and we have this huge part right here. It's kind of big, right? This is, all of this first part right here is actually the reinforcement learning part, okay? And down here, it's another file, okay? This is the second part. And this is the environment, okay? This is the whole tic-tac-toe part, okay? And now I'm just gonna run it right here in the collab first. Okay? And now I'm gonna run the environment, okay? Perfect. So now this is the game right here. Let me just. Okay. So we're gonna be playing as X, and the AI is gonna be the letter O, okay? So I'm not gonna play hard right now. So I'm just gonna let's first put it right here, okay? In this position right here. Okay, so we just put it right here, and the AI put it right here. Is that good? Bad? Maybe not that bad. Any? Well, what is it? Oh yeah, we are X. Yeah, and the AI is O. Okay. Okay. Yeah. So far so good, right? But now I'm gonna try to go for the score, right? So I'm gonna put it right here. Oops. I'm gonna try to put it right here to make a full column right here, right? So. Not so smart, right? You put it right here. Nonsense, right? So yeah, the AI was not so smart right here, right? So I'm just gonna finish the game right here. And yeah, what did it go up? Yeah, so we won the game. But the thing is that I didn't tell you something. Right here at the reinforcement learned file, let me just go right here to the top and find it. I'm looking for the for loop. Just 1 second. Where is it? Yeah. Hold up, I can't see this one. Okay, right here. Fine. In our reinforcement learning, I actually put it for our machine learning to just go into the environment just once. And this is actually not good, right? I mean, the AI is not gonna learn anything at all if it just goes once into the environment, right? So how many times do you guys think we could put it right here?
5.
Do you think it could be enough? Let's try something higher. No, okay, no.
9 factorial.
I don't know it off the top of my head.
I don't know either.
Okay. Yeah.
200.
200. Okay, let's try that. Okay, so now let's run that.
I was saying it because there are like 9 positions.
Oh, interesting. Oh, I don't know. It's a very interesting logic. I don't know if it will work though, but it's very interesting. But for now, I'm just gonna try 200. Okay. Okay, so we run that, and then we run the tic-tac-toe. That's right. So I'm gonna try to play the same strategy right here. So let's see if it makes anything better. Let's try it. Okay. Well, do you guys think this is better than like putting right here at the top?
Yeah.
Yes.
Okay, cool. I like that. So yeah, so let's try the same strategy. Let's see if it's gonna try to block our score right here. So 1 and 2. It did. Interesting. Well, we could just put it right here, right? To block. Let's see if it's
But test this,
yeah.
ability.
I'm just gonna do that. But first, I think I'm gonna try to put it right here at this point right here, because I wanna see if the AI is actually gonna try to win the game, and not just some like random position, right? So let's see. So the AI is getting smarter now. Interesting. This is pretty cool, isn't it? I mean, honestly. And I think this is the kind of stuff that I personally want to see like in the future of gaming. Like I play video games a lot, so like I don't want it to just like fight some like basic boss or something. This would be very interesting, like for like the boss to have some kind of own brain or something, right? This could be very interesting, like in this industry. If you guys are interested into gaming, this is something that you guys should take a look at. Now, I want to just finally just test something before leaving this. Just making sure. Right here. So, just make sure I'm gonna put like a 1,000. Gonna make sure that this is actually really, really good, the AI. Now I have like a interesting question now. Let's say that I have right here one of the best players in the world in tic-tac-toe. And I have another one of the best players of tic-tac-toe in the world. And I put them to play together. What is going to be the result? Who is going to win? Theoretically, it's supposed to be a tie, right? So that's the idea. So if we play with AI in this game, what we're supposed to get is a tie. So this is what we're gonna try to get, as long as we are good as well. So I'll let you guys decide where should we play now. Middle. Middle. You all agree? Okay, let's do that. Ooh. Where now? 1-1. Any more ideas?
I think 2-1.
I'm gonna say bottom right.
2-1. Bottom right. Well, technically this one would be the same as.
Yeah, it's really
Okay, so maybe this one then.
Yeah.
Bottom right. We all agree? Let's try that. So it should be 3. I mean, there's nothing we can do, right? I'm gonna have to block it. So we're gonna block it by putting 1 and 2. And now we blocked us. I mean, that's the idea of like putting the 2 best players. Where now? The one at the top, right? Yeah, agree to 2. Oh yeah, sorry. Nice. Oh yeah, my bad. Two more. Sorry. Yeah. Oh yeah, and it blocked us right over here. Yeah.
Yeah, so
It's a type. So yeah, technically our model is perfect. Did you guys like that?
Yeah.
It's like you're seeing AI in action, right?
I have a question.
Yeah, of course.
So in the PowerPoint, when we first started going over reinforcement learning, tying it with rewards and punishments, like when you train an animal. What classifies as rewards and punishments for a computer?
Well, it depends. Like I would say, it depends. Like in the environment. Like for example, like our reward here in this environment would be like to make like a full row, right? So this technically would be like the reward. But if you like it, if you put it at somewhere random, then it's not something good.
Not working towards one. So when we were changing the, I guess, like number of
Iterations, yeah, exactly.
what was that doing? What was that work?
So, well, basically, it's just like to make sure that the AI is going enough times to process a lot of different like different actions.
So it's running through the simulations of the game.
Yeah, with itself. It's like playing with itself a lot of times, over and over again.
So that's why when you put one at the beginning, it was not making smart decisions.
Exactly, it was just
The one
some
where
random.
Ones, yeah, the random.
It was
Got
just random. Actually, I love that in those parts. Okay. So this was reinforcement learning. Okay, perfect. Let me change it right back. Oh, and also, I think this code for the tic-tac-toe should be available in the Explore Hub, okay? If you guys want to access that, okay? Oh, by the way, the name of this model, this algorithm is right here. I'm just showing you. It's aims. Wait, it's not here. Oh gosh. Should be MCTS.
I showed that as one of the class names earlier.
Oh, it wasn't right. Oh yeah, it's right here. Yeah. So this is the name of the model that is being used for this game. It's reinforcement learning. Perfect. Let me change it back. Now, in this last 30 minutes, we're gonna talk about a little bit this famous model that we can use. It's a very beginner friendly, but it can still be used as a very common machine learning model. K-nearest neighbors. Okay. Yes. Okay. So for this model, the way that we can understand that, I don't know if you guys have like heard like this called something like that like it says like tell me like your friends or something, and I tell you who you are, something like that. This is actually the idea in K-nearest neighbors. What do I mean by that? So, let's say that we have this data set right here. And right here, this is first, is this supervised learning or unsupervised learning? If you are trying to,
Unsupervised.
we are not trying to group right here. Okay, we're trying to first try to tell if it is like blue or green. Supervised. Yes, perfect. But now, is this regression or classification? Classification, right? Okay, so we're not working with numbers here, we're just working with colors. which are blue, oops, blue and green. Perfect. And these are the two targets that we want to classify as. But so here's the idea. Let's say that I put some random data point right here. And we only analyze the data points around it. For example, let's say that we just analyze the three closest, the three nearest neighbors around this data point. Then we have this one, and this one. You agree? Okay. So based on that, if we have two green and one blue, theoretically, what data points this is going to be? Is it going to be blue or green? Green, right? I heard green. Yeah. So this is the idea with k-nearest neighbors. We are just analyzing the data that is around the data that we want to classify something as. So, but the interesting thing is, what if we want to analyze not just the three nearest neighbors, but we want to do 6 neighbors? And now we have 4 blue and 2 green. And now with this idea, what could be what would be like the most likely one here? Which one? Blue or green? Blue, right? So you can see that this kind of stuff can be precise, but not as much. It depends. So this is the kind of stuff that we have to worry about. The parameters that we set, the number of neighbors, for example. Okay.
So this model is essentially just averaging, getting the highest, it's averaging what's in the data set, whatever appears the most is classified as that. It's just taking like
The distance. The distance, like.
Right, in its nearest neighbor, so whether it's 3 or 5 or 6, it's looking at what appears the most, whatever appears the most,
Around.
instead of just guessing that, then what we're trying to identify is those.
Well, like this right here, it's given to us. We give it to the model.
Right.
Yeah. So we use these two so that AI can learn what is the data set, and then we can use that to classify new data.
Okay.
Does that make sense?
That makes sense.
Does that answer your question?
The new data being star.
Yeah. So we're just storing this data.
Right.
Okay. And basically what we're just doing here is calculating the distance. So the thing with this model is that it doesn't take a lot of computational power to train the model, because we're just storing the positions, but like the positions of all this data. But the problem is when we actually have to do the prediction, because to be able to get the nearest neighbors, the computer is actually going to calculate the distance with every single model, every single data set, like this. You see that it is calculating the distance to get like the nearest neighbors, like this. And then with this distance, then we can tell which data set are the closest one, which are this right here, for only 2 neighbors. Does that make sense? Guys have any questions? Any more questions? So yeah, so this is the KNN model. Now I have an interesting question right here. Do you guys think that this model could be used for regression to predict number? Yes. Show of hands. Yes.
Yes,
Or-
we have data.
I see three people to predict the number of what? Anything. Could be anything. Just use this to predict actually numbers, not just like classify something. And the answer is yes. We can actually try. Let's say that we have the three nearest neighbors right here. And let's say we have some values right here. I don't know, 90, 60, I don't know, I'm just guessing numbers. Okay, so if we have these three nearest neighbors, what could be the value of this data point that we're trying to predict? How would you calculate that?
Maybe an average, I would agree.
Exactly. We calculate the average. And if we do the, well, I can do it right here real quick. 90,
Maybe 250,
250 divided by 3, which is, well, something around 80 or something, right?
yeah.
Like 80 or something. So yeah. 8 or something. So yeah, you guys can see that we just predict like a real value with this type of model. Maybe it's not that effective, but it's just something to also keep in mind, okay? Guys have any questions? No. Okay. So in this last minutes, 20 minutes that we have, we're gonna actually work on a quick project right now, just to show you like in our real world. So we're gonna work with everything should be in the same Google Colab with the unsupervised learning is in the supervised learning section. But first, I want to tell you about this data that we're gonna try to predict. Okay. So, what's the story here? So some customers are stopping from using the company service, and basically what we're trying gonna try to predict here is gonna tell if a customer is gonna stop from using the company service or not. So, and this is called customer churn, okay? So this is gonna be a type of project that we're gonna try to predict as something as true or false. So, is a customer churn or not? And is this regression or classification?
Classification.
Classification, perfect. So now, and before we go over the code, I want to first review a little bit, like the whole process of building a whole model and building a project. This is gonna be the most important part here, okay? That I want you really guys to like have this in mind, okay? So, what is the first step of building a model? First, we get our data. And out there are many websites with lots of data sets available that you can actually use to build some kind of personal project. And by getting the data, the second thing that we're gonna need to do is we're gonna have to work with our data. Because what is the thing here? Not every time our data is gonna be perfect for our models. So we're gonna have to be able to adjust our model or our data so that our models can understand it. Maybe there are some like empty rows, maybe there are some string values that the model won't understand. This kind of stuff is really important so that we can make sure that our model is gonna fully understand our data set. Okay? And that's why I wanna say that again, when we are working with AI, we work with data as well, okay? And after that, after we make our data set perfect, we do the training, which is actually like just a few lines of code. It's not that much. And then we do the predictions, and after that, lastly, we do our visualization to compare our results and just to be able to evaluate our model. Any questions on that? Okay, it's really important that you guys get like this idea of this sequence, like this pipeline that we're gonna follow, okay? Because this is usually the plan for when working with an AI project, okay? So I'm gonna change it over here. So this is the local lab. Okay, so we just did over here the unsupervised learning. So we just did the unsupervised learning, and now we're gonna work with the supervised learning, okay? So we're gonna close that for now, and we are gonna open the supervised learning. And also, right here, make sure that you guys download the dataset file. It's also available right here. Right here. So, wait. Let me refresh that. Okay, okay. So this is the Google Colab right here, and right over here, this is the data set, okay? That you guys are gonna have to download, and this is the data that we're gonna be using to train our model and be able to predict stuff as well. So when you download that into your computer, yes.
Doesn't let me download it. You just opens it on stuff.
What is it saying? Yeah, show me.
So when I try to download it, you just opens it as a zip directly, and it doesn't give you an option to.
Download. It doesn't.
It is like a website. Shows it like this.
Oh, wait. Okay, let me see if I can find it.
Right.
Oh, but thanks for letting me know. Hold up. You guys maybe try. Well, we have here the supervised learning. This is the data. Can we download that? Okay. Yeah, perfect. Okay, so this is the GitHub with, again, this with all the code, and right here you should be able to download it. Okay? Right over here. This to download the data set, okay?
It's in the workshop 2 folder of the GitHub, right?
Yes, yes. Workshop 2 in the supervised learning section.
The data.csv.
Yes, right here. This is the one. And then we can download it over here.
Yeah, that one's.
Oh, okay, perfect. if you guys are having any trouble, just let me know, okay? And then once we have that, you can upload it over here. You just right click and you upload this data. It's not. Now once you have that, maybe gonna need to change the path right here. If it's not the same name. But if you right click over here and you copy path, you're gonna have to include right here so that we can make a data frame from our data set. Okay? And this all over here is all of the libraries that we're gonna be using. And right here we have scikit-learn, NumPy, pandas, matplotlib, and again scikit-learn, okay? Don't worry about all of this stuff right over here. This is all part of the data handling part, which I'm gonna cover more of that in the next workshop, okay? But for now, all I wanted to see the process of making this project. So if you guys run this code, you guys should see that we have more than 7,000 data points and 21 columns, with 20 being the features and 1 being the target, which the one saying true or not true, true or false. Then over here, this section, it's all the data handling, okay? I'm not gonna go over this now, okay? But this is basically just making sure that our model can understand our data and we are presenting the best data set. Oh, thanks, man. Okay, and you guys should be able to run that like this. And you guys can skip that. And right over here, this is the training part, okay? And you guys can see that it's kind of similar the way we did with the KNNs, where we have we create our model, KNN, K nearest neighbors, and we have always a class. And again, we include the number of neighbors that we wanted to analyze, the weights, which is going to be based on distance, and the metric, which is Euclidean, okay? Well, we can always play around with these parameters, and all of this information is actually available in the scikit-learn document. After that, we're gonna write this fit to train our models, X string and Y string. Remember when I told you guys that when we have a whole data set, we have to split it, right? Into a training and a testing set. This happens right over here in this line of code. We have a function, train test split. It's the one that we use. And we pass the parameters, which these are the features, the X, the Y, the target, which is the term you guys can see here. And these are all the features. Okay? And this is the test size, which we want it to be 30% of our whole data. And this is again just the render state, which is for it to just what is it? Like you just put it there. You don't have to change it. And right here we get the X for the train, the X for the test, and the Y for the train, and the Y for the test. Perfect. Then we train our model here, KNN, and we write dot fit. Okay. And again, if you you guys have any questions, I'll do my best to answer them, okay? Just let me know. And lastly, we're gonna predict, and it's actually just a simple line of code. We do KNN dot predict. So here we use the fit to train, and here we use the predict to predict our model. And we want to predict the features given by the X test, okay? And then we get the predictions right here. This is important because now that we have the predictions, now we can use that to compare with the Y from the testing data. And with that, we can use that to get our accuracy. And if you run this, you get our accuracy right here. 77%. Is that good? There's always things that we can do to make it, to optimize our model, maybe something in the data that we could do. I don't know, there's actually a lot of stuff, you know? And right here in the end, just we can plot our results. And when we run that, this is what is called a confusion matrix. It's very important in machine learning. So what is it actually saying here is that we have the true label right here, and this is what we predict. So basically what it's saying here, if we predict churn, and the actual churn, we got this amount of numbers right. And right here, this is what we predicted wrong. So we predicted as churn, but it's actually not churn, no churn. So this is what we got right, and this is what we got wrong when we predict this. And when we predict as no churn, so this is the actual stuff that we got it right, which is a lot, honestly, right? And right here, when we predict no churn, and it's actually churn, then this is the amount that we got it wrong. Does that make sense? This way to visualize and to be able to evaluate our model. Does that make sense? It's very interesting, right? Okay. And this is right here, the function that we do, confusion matrix, and we put our Y test, which is the actual stuff, and what we predict right here. Okay? Do you guys have any questions? Okay. So now that we have some time remaining, I want to give you guys a little challenge. So we have this data set right here, right? And you guys saw that we got this accuracy right here. So if any of you can make a better model than this one right here, I'm gonna give you the small gift in the next workshop, okay? But you have to show me right here. The only rule is it's gonna have to be the same data set and the KNN model, okay? So what I would suggest you to do would be to play around with these numbers, with these parameters, maybe change the number of neighbors, maybe include some other metric right here. Or if you feel like you can do something more advanced, maybe you can work with our data here. You guys see that I removed some columns from our data set. These are columns that I removed. Maybe they weren't important, I don't know. These were just some columns, some features that I thought it weren't so necessary. Maybe you can try to include some of them. It's up to you. You can also try deleting more columns. It's all up to you. Okay. But this part here, you don't have to change it much. Just like scaling the numbers. I'm gonna talk more about all of these data part. Oh yes, sir.
So for example, to include those removed columns, you just take them out from the columns removed.
If you want to like remove more columns, you just
No, like if you want to include some of the ones that you removed.
if
take
you
them out of that list.
yeah. So this like are the this
For,
is
if I want to add, like if I want to include payment method, for example.
okay. So if you want to include the payment method, then you just delete it
You
first.
say that I do that. Okay.
Like this.
Yeah. Okay.
And maybe you can try deleting more columns out of it. I mean, we have in total 20 features or something.
Only one, I think it was.
20 features. So you can always play around with it.
Yeah.
And as always, guys is always gonna be available in the Explore Hub, in the GitHub, and all of it. Okay. Guys, have any questions now? Any final thoughts? No. So I guess this is gonna be it for today. Thank you so much, guys. I'll see you guys in the next workshop next week. Okay? Thank you so much. Love it. Was fun.
So are we,
Yeah.
you said we're gonna be building an actual project in the next workshop?
In the next one, yes. It's gonna be a electricity bill predictor.
Is that something we're gonna be coding line by line, or it's just gonna be?
I'm not gonna do line by line, just like the important stuff. And it's gonna also be the same I did in the last one. It will be another final project. Like a beautiful one so you can put in your resume. Thanks guys. Oh yes, of course.
Do you need Python and VSCode for the project?
For the last one, I would recommend so because when you want to include something like that in your resume, it's good to be from your VSCode, for example. So you can put in your GitHub and